In the early months of 1942, as the United States surged into a global war unlike any it had faced before, there was a quiet revolution unfolding. Not in the skies or on the seas, but in the muddy, forgotten corners of the world where engineers and laborers bent steel and sweat to the service of flight. The U.S. Army Air Forces were expanding faster than any air arm in history, and with them came a daunting question that no one in Washington could easily answer. Where would all these planes take off and land? Every bomber, every fighter, every transport needed a runway, and in a world war fought across deserts, jungles, and ruined farmlands, there were precious few places to build one. In the pre-war years, airfields had been concrete or grass, fixed and permanent. They required weeks, even months, of grading, compacting, and curing before the first aircraft could roll down their length. In Europe, the German Luftwaffe had relied on well-prepared bases close to home, meticulously built with concrete runways and elaborate hangars. When their engineers studied the challenges of forward operations, they concluded it was virtually impossible to build a proper airfield in less than 6 weeks. Anything faster, they believed, would crumble under the weight of warplanes or tear apart under the pounding of their wheels. That assumption would soon be shattered. Half a world away, American engineers were working under the banner of necessity. In 1939, when war first broke out in Europe, a handful of civilian contractors working for the U.S. Army Corps of Engineers had begun experimenting with the idea of a portable runway. They envisioned something that could be shipped in sections, assembled by hand, and sturdy enough to bear heavy aircraft like the B-17 Flying Fortress or the new C-47 transport. It was an audacious idea, born partly from practicality and partly from desperation. The breakthrough came in 1941 at the Carnegie, Illinois Steel Company and the Steel Company of Canada, where metallurgists began experimenting with perforated steel sheets that interlocked like giant floor tiles. The holes served two purposes. They lightened the weight of each panel, and they allowed rainwater and debris to drain through instead of pooling on the surface. Each piece was roughly 10 feet long and 15 inches wide, with slots and hooks on the edges so they could snap together without welding or bolts. The result was a sort of metallic carpet, light enough for transport, strong enough to carry a loaded bomber. They called it pierced steel planking, or PSP. In the field, it earned other names: Marston Mat, after the airfield in North Carolina where it was first tested, and later Marsden matting, a mispronunciation that stuck in the Pacific. Whatever the name, it was a marvel. Engineers quickly discovered that with PSP, they could transform a field of mud into a runway in a matter of days. The concept reached its first true test in the North African campaign. In late 1942, following Operation Torch, American Engineer Aviation Battalions, the unsung units responsible for building and maintaining airfields, landed behind the invasion forces. Among their supplies were hundreds of tons of PSP panels stacked like enormous bundles of steel shingles. As soon as the beachheads were secured, the engineers got to work. Bulldozers flattened the rough terrain, graders leveled it, and teams of men laid out the PSP like railroad track. Each piece clicked into the next with a satisfying metallic ring, and within hours, the glinting runway began to stretch across the desert. To the astonishment of local Allied commanders and utter disbelief of their German counterparts, fully operational airstrips began appearing seemingly overnight. The Luftwaffe, accustomed to weeks of engineering work for a new forward base, could not comprehend how the Americans were able to launch fighters and bombers from what had been, only days before, barren sand. German intelligence reports initially dismissed the claims as propaganda. Yet as the campaign wore on, reconnaissance flights began photographing these strange, glimmering runways that appeared like metallic scars on the earth. The secret was not just the steel matting itself, but the organization that supported it.
Each Engineer Aviation Battalion was a self-contained miracle of logistics and discipline. Comprised of roughly 800 men, the battalions carried everything needed to create an airfield from scratch. Bulldozers, graders, dump trucks, cement mixers, and of course tons of PSP. Their motto was simple and proud: first in, last out. When they landed on a beach or moved into newly captured territory, the battalions worked around the clock. Day and night, in heat or rain, they cut, filled, and compacted the soil until it could support the steel panels. They built drainage ditches, control towers, and fuel dumps. In some cases, an entire airfield, runway, taxiways, and parking areas was completed in 72 hours. That pace was unheard of in military history. One of the earliest and most dramatic examples came during the Sicilian campaign in 1943. The U.S. 12th Air Force needed forward airfields close enough to strike Axis convoys and support ground troops. The engineers, working with their PSP, constructed a 5,000-foot runway near Gela in just 3 days, despite constant Luftwaffe raids. When the first P-40 fighters took off from that strip, German observers were stunned. Only a week earlier, that patch of ground had been a wheat field.
Similar scenes played out across the Pacific. On the coral islands of the Solomons and later on the atolls of the Central Pacific, American Seabees and Army engineers wrestled with volcanic ash, swamp, and jungle. PSP allowed them to overcome terrain that would have defeated traditional construction methods. On Guadalcanal, where heavy rains turned the red clay into knee-deep sludge, the arrival of PSP panels transformed Henderson Field into a reliable base for operations. Pilots who once feared their planes would bog down in mud could now take off and land with confidence. The process was grueling. Each mat weighed about 66 pounds, and hundreds of thousands of them were needed to create a single runway. Soldiers worked in teams, hauling, aligning, and locking the panels into place. The holes in the steel made the planking easier to grip, but tore at hands and boots. Many men wrapped their fingers in tape or rags to keep from bleeding. In the heat of the tropics, the metal became too hot to touch. Yet they persisted, because every hour shaved from construction time meant lives saved at the front. German commanders were not blind to the transformation. By 1943 and 1944, they had begun encountering PSP-built runways across captured or contested areas in Italy and later in France. Luftwaffe engineers studied captured sections of the steel planking with a mixture of awe and envy. They quickly realized the genius of its simplicity. Unlike the reinforced concrete of German airfields, which required enormous quantities of materials and skilled labor, the American system depended on standardization and speed. Any unit trained in the procedure could assemble a serviceable runway with minimal tools. Field Marshal Erwin Rommel, the famed Desert Fox, reportedly remarked on the ingenuity of the American engineers after the North African campaign. He had seen firsthand how swiftly U.S. air power could follow the advance of ground troops, keeping pressure on his supply lines. Though no formal German record quotes his exact words, post-war analyses by Allied intelligence confirmed that Rommel's staff was deeply impressed and unsettled by the logistical mobility of the U.S. forces, of which PSP was a crucial part. The steel planking didn't just make runways, it became a universal tool of war. Engineers used it for roads, parking areas, hospital floors, temporary bridges, even docks. Tanks and trucks rolled across PSP causeways that led from landing craft onto beaches. In muddy terrain, it served as flooring for tents and workshops.
The modular design meant that it could be taken apart and moved wherever needed.
In the Normandy campaign of 1944, PSP reached its zenith. As Allied forces broke out from the beaches, the engineer aviation battalions followed close behind. Within days of the invasion, new airfields, designated advanced landing grounds, were springing up across the French countryside. Each consisted of a single PSP runway, fuel storage, and minimal facilities. Yet they were enough to keep fighter groups and reconnaissance squadrons in the air. The Germans could not keep pace. Their doctrine required long, elaborate construction processes. The Americans, by contrast, seemed to make airfields grow like weeds. By mid-1944, more than 100 of these forward airfields had been built in France alone. Pilots marveled at the sight of them, gleaming silver ribbons stretching across farmland and hedgerows. They were rough and noisy to land on, the perforated metal clattering under the wheels, but they worked. The sound of an American fighter touching down on PSP became one of the defining noises of the Allied advance. At the same time, on the other side of the world, PSP was changing the very nature of island warfare. In the Pacific, the U.S. Navy's construction battalions, the CVs, had adopted the same technology for their own use. After the bloody battle for Tarawa in 1943, where the lagoon's soft sand had made traditional runway construction nearly impossible, the CBs laid down PSP over coral and crushed rock to create one of the first usable airstrips on the island. From that moment, every major island captured by the Allies sprouted runways almost immediately. By the time American forces reached the Marianas in 1944, the system was perfected. On Saipan and Tinian, engineers using PSP and other prefabricated systems built vast airfields capable of launching B-29 superfortresses against Japan. The speed at which they worked was breathtaking. One engineer later recalled that it seemed the airfields were chasing the front line. That sense of relentless forward motion defined the American way of war in those years: industrial, mobile, and unyielding. The Germans tried to adapt. Late in the war, they experimented with their own forms of portable matting, including wooden panels and aluminum grids, but none matched the efficiency or strength of PSP. The Allied air superiority by that stage made experimentation difficult. Any large-scale German construction project was an immediate target for bombing. What had begun as an engineering innovation had become a strategic advantage, one that even the most brilliant enemy tacticians could not overcome. Behind the success lay a powerful industrial machine. American factories churned out PSP by the millions of pieces, over 100 million by war's end. Entire trainloads of the steel sheets rolled out daily from mills in Pennsylvania, Ohio, and Illinois, destined for ports where they were loaded onto Liberty ships. The sight of those endless stacks of pierced metal became a symbol of America's wartime productivity. Soldiers joked that the United States had figured out how to pave the world with steel.
Yet, for all its importance, the story of the men who actually laid the PSP has often been overlooked. The engineer aviation battalions did their work in obscurity, usually behind the lines, without medals or headlines. They faced danger not only from enemy fire, but from disease, exhaustion, and the unforgiving environment. In New Guinea, men worked waist-deep in mud to install PSP on jungle clearings, while in Italy they toiled through the rain and cold. At Normandy, engineers came under artillery fire as they assembled airstrips near the front. Still, they kept at it. They knew that without their runways, the fighters and bombers could not fly, and without air power, the army could not move. In letters home, many engineers expressed quiet pride in their work. "We don't shoot guns," one wrote, "but we make it possible for others to do so." Another described the thrill of watching the first plane take off from a strip his unit had finished. "It's like watching your kid walk for the first time." Such sentiments capture the spirit of those unsung men whose labor helped turn the tide of war. As 1945 approached and victory drew nearer, PSP continued to play a critical role. In the final push across Europe, American engineers built airfields in Belgium, Luxembourg, and Germany itself. Some were temporary, others became permanent bases that would serve NATO in the post-war years. When Allied forces liberated concentration camps and devastated towns, PSP was often used to create makeshift landing zones for medical evacuation and relief supplies. After the war, the usefulness of pierced steel planking did not end. Surplus matting was sold around the world, and many countries adopted it for civilian airfields, roads, and even farm use. In remote areas from Alaska to Africa, it became the foundation for temporary runways that endured for decades. In some places, you can still find the old panels half buried in the ground, rusted but intact, a silent reminder of the engineering miracle that helped win the war. Historians looking back have come to see PSP as more than just a technical curiosity. It symbolized a broader truth about American warfare in the 1940s, that victory depended as much on innovation and logistics as on courage and firepower. The Germans, with all their brilliance in aircraft design and tactics, had failed to grasp the power of rapid construction and mobility. They built fortresses, the Americans built highways through chaos. When post-war German officers were interviewed by Allied analysts, many expressed disbelief at how swiftly American air operations had advanced during the war. Several admitted that their pre-war calculations had been completely wrong. Where they had assumed that building a reliable airfield required 6 weeks, the Americans proved it could be done in 3 days. That realization, simple yet profound, captured the essence of how industrial ingenuity had rewritten the rules of modern warfare. In later decades, veterans of the engineering aviation battalions would gather at reunions, gray-haired and proud, to reminisce about those frantic days. They would recall the clang of steel underfoot, the smell of diesel and hot metal, and the satisfaction of watching planes thunder into the sky from a runway they had built only hours before. For them, the PSP was not just a piece of equipment. It was a symbol of teamwork, perseverance, and faith in the American way of solving problems.
Today, when historians tell the story of World War II, they often focus on the great battles, the beaches of Normandy, the skies over Britain, the ruins of Berlin. Yet beneath those grand narratives lies a quieter story of men with shovels and wrenches, of steel sheets hammered into earth, of sweat and ingenuity. The pierced steel planking was not glamorous, but it was revolutionary. It turned mobility into a weapon, and in doing so, it helped the Allies reclaim continents. In the end, the story of PSP is the story of how a simple idea, steel panels with holes in them, could change the course of a global conflict. It is a reminder that wars are not won only by generals or pilots, but by the countless engineers, builders, and dreamers who make the impossible possible. When those American aviation engineers first laid their metallic mats across the mud of North Africa, they were doing more than building runways. They were paving the way for victory. For the German commanders who once believed that constructing a new airfield in less than 6 weeks was impossible, the sight of American fighters taking off from a freshly built PSP strip was nothing short of shocking. It was proof that the rules had changed, that industrial might and ingenuity could outpace even the most rigid doctrine. And for the men who laid that steel, often under fire,
It was the quiet satisfaction of knowing they had helped turn the tide of history. Long after the guns fell silent, the echoes of their work remained, across the deserts of North Africa, the jungles of the Pacific, and the fields of France, where rusted PSP still lies beneath the soil, a lasting testament to American innovation. It is there, in those forgotten fragments of steel, that one can still hear the clatter of hammers, the shouts of engineers, and the distant roar of aircraft climbing toward victory.